Assalamu alaikum. My name is Hanan Ahmad and my registration number is 21T25. Today we are going to discuss DSP lab number 5 that is submitted to Dr. Muhammad Jamil. So in the task 1, basically we have to given 4 values of array of x and we have to find discrete Fourier transform and inverse DFT. For this, first of all, we have to define a discrete Fourier transform function and then assume n is equal to length of x where y is equal to number of zeros. Then we apply a for loop that ranges from 0 to n minus 1. After this, we apply condition for loop that is range from 0 to n minus 1. After this, we use AND, and after this, we apply the IDFT function the same as above. N is equal to length of y, x is equal to zeros, where for loop range from 0 to n minus 1. And this function, then we have given these 4 values of x. So first of all, we have to done for the first one 2 3 4 5. So we have to call function of discrete Fourier transform. After this, we use display command that is used to display the DFT coefficients, and then we calculate the inverse DFT of y using IDFT command. After this, we use display command to display this IDFT function, and then we are going to discuss for second value of x that is 2 5 8 9. Same as above. First of all, we define DFT function. After this, we use display command and then IDFT function call and then display that IDFT function. Same as above, we do for the third one where y is equal to my DFTX as we have to call DFT function, then display it, then call IDFT function and display it. And the last one remaining for values of x. So we again calling the function of discrete Fourier transform, then display it, and then call IDFT function and then display this. When we simulate this code, we obtain 4 outputs. As in output 1, these are the DFT coefficients, where these are the IDFT coefficients. In the output number 2, that is for the second value of array of x. For this, there are DFT coefficients and these are IDFT coefficients. In the third output, as we can see, there are also DFT coefficients and IDFT coefficients. In the output 4, these are the DFT coefficients and these are the IDFT coefficients. So in the task 2, first of all, we define 11 values of x that is range from x1 to x11. We assign arrays for these values of x. Then we use temp command to plot the discrete graph and use FFT command. Then title this graph. As we can see, x9 is equal to n is equal to 32, where 32 is the number of samples. So in the task 3, we have array of x that is 1 2 3 4. Then we use command of FFT, that is Fourier transform. Then we let a value of x including real and imaginary values. It is obtained as a result of Fourier transform. Then we use x real as we have to find real values in this output. So the real values are 10 minus 2 minus 2 minus 2 as we can see here. Then we use x imaginary function, that is imaginary of x. So we have to find imaginary values on these x. So the imaginary values are 0, 2, 0, minus 2 as we can see. Then we have to find absolute value of x. For this, we use this function absolute bracket x. Then the output will be 10, 2.824 and then 2 and then 2.824. So in the task 4, we have 11 values of x that range from x1 to x11. So basically we have to find imaginary values for this and then angle values, and then absolute values. So first of all, we have to find for FFT for each value of x. For this we use separate function for x1 to x11. Then x1 imaginary is equal to absolute of x1, then phase is equal to angle of x1, and power is equal to x1 imaginary की power minus 2. Basically we have to find imaginary values, then phase, and then power of the above functions. First we have to assign range from x1 to x11. So at last we use subplot command, then stem command, subplot 3 comma 1 comma 1, and then we use subplot command for the second graph, that is like titled as phase spectrum of x5, and where x label is frequency of k magnitude and y label is x of k radians. And then we use subplot command again, and then also labeled as it. When we simulate this code, we obtain the three graphs. First one is magnitude spectrum, and the second is phase spectrum, and the third one is power spectrum.